Sven says you should probably already know us. How many people have seen us over in the public area playing with lockpicks and the like? How many people have come by and actually used the lockpicks and such? How many people are taking a set home? We have a handful left. Yeah. Proxmark coming up and running. We have all kind of fun live demos. We don't consider a talk worthwhile unless our butts are on the line with a demo that could completely epic fail all over the place. Bloop. Yay. Now you're giving it away. We've already shown people how awesome we are. They have to know there's risk involved. Okay. Bam.
Okay. Yeah, I'm gonna steal this.
Magic.
All right, DeepSec 2010, we're going to talk about electronic locks and how secure they are or are not. So what do we mean by electronic locks? Well, no, it's not a lock, it just has a power cord on it. Electronic locks are relatively new. They have been created as a kind of a response to the demand in the market where people want some additional features. But first, you have purely mechanical locks. These are locks that don't rely on external energy or electricity in any way. This has traditionally been the only type of lock available for, thousands of years in one form or another. Then there's purely electronic locks. These are, locks that are not really so much locks as just access control devices or access control systems. Anything with a keypad or with a code. Anything password-based, things where there's no mechanical key, mechanical component. Then there's the hybrid, the merging between these two, which we call electromechanical locks. These are mechanical cylinders that operate normally as they would without any electronics, and then usually the vendor or the manufacturer will throw some magic electronic stuff in there and supposedly either make it more secure or add more features.
Because electrons make everything better.
Yeah, and why would they do this? Why are we making locks more expensive, more complicated, and possibly more insecure? Well, there's a couple different features. So first of all, you have a physical token that's embedded into the key. So there's a certain amount of key control in there. So assuming the electronic system is secure and you can't copy that electronic token, then you can't, if you make a clay mold impression of the key or something, you can't easily duplicate the key. So that's one idea. Then you have different levels of security that you can apply. You can master key the system electronically.
Which is much better than master keying mechanical.
Right. Mechanical master keying is labor intensive. It's very difficult. It requires a great deal of skill from the locksmith to do it correctly. And in most locks, mechanical master keying makes the lock easier to pick. It makes it easier to compromise because you're adding more shear lines. You're basically saying there's more keys that will work. It's the equivalent of having more than one password for a particular user account. The more passwords you add, the more susceptible it is to a brute force attack or to an MD5 collision or something.
So if you want to have these working stiffs coming in every day, but the boss can come in at 2 a.m. and come and go as he pleases if he wants to. Of course he doesn't. He sits in the airport lounge, right? But you need a way to do that. And you always need a way to have just the least paid individual in the whole system can get everywhere, of course. And that's the threat we never talk about except in the social engineering side of things.
You can also do other cool things, like you have log-on hours on your computer. Well, you can have log-on hours for your lock. So even if an employee has a key for the building, they may not be able to get in if they're not coded for that time slot. So maybe during the day, a subset of employees are allowed to enter the building, open the main door, lock up, etc., but they don't necessarily have a legitimate reason to do that at 3 in the morning. And this is all stuff that you can control via the programming, via the configuration. And so it's really neat. It actually makes it very, very, very nice when everything works correctly. You have audit trails. So
very important stuff for a lot of facilities.
Who entered, when they entered, when they left. You have all that information. all
When
your
it works.
access logs.
And when it fails, woohoo, does it fail epically.
Yep.
So is any system, purely electronic? When we said the second category, just electronic. In a way, I would say, no. You could have, like, this is Mr. Uber hacker, you can tell by his hackery clothes and laptop. So he's going to ponzor the bar where he's sitting, and he's like, I'm going to hack this place and get myself another glass of wine. Well, ultimately, he can't do that, right? You can't send electrons somewhere and make a bottle come over and pour the glass. Like, he could fake credit card data to not pay for it, or he could maybe, get the bartender's attention by setting off the implant in his brain. Who knows? But electrons can't, do stuff. If I want to knock this over, like, I can't do that with electrons. I can't, no matter how good I am with my laptop, I can't make that happen. So no purely electronic lock exists. Most that we say are just pure electronic really do involve an electromagnet or a small motor somewhere. And there's a beautiful series of ways that these can fail all over the place, and we're just going to show you some of those electronic attacks because we think they're really freaking funny. So this was a hotel that we stayed at in Malaysia. This was a hotel safe. And the inside of the safe actually was controlled by a little, you'll see, just a servo motor. So this is an advisory video we shot. We don't have to watch all of our boring text. But here we are. You can see we could easily have done this from the inside as well. We're just showing you from both sides. We reached through a small hole in the panel. We just kind of pulled the front panel off the safe. And if wow, can we turn these lights out anyway? Is that possible? No?
No one is responding.
No one's responding? Can we make the screen visible? Woot! So you'll see we're just fishing wires. If you know where the wires are, and we knew because we had a block of 3 rooms. We took our safe apart, took another safe apart to borrow a battery that you'll see in a minute, and on another safe we tried it just completely blind, and we were able to do this with a little bit of recon. So it's there we go.
Much better.
Nice.
So there you go.
Exposing the wires, just taking off some sheathing here, that's the only thing that's controlling that little motor that's going to crank and turn the bolt. If you expose the wires and just spike a 9-volt charge on them, we guessed that the system wasn't doing any voltage regulating. We said there's a 9-volt battery in here. I'm guessing it's just powering or not powering the motor. So here we have the safe. In a second, you'll see it locked. Someone's just going to jam a lockpick in the front hole in order to pull on the door. And the hardest part in all this was just getting these badly stripped wires to touch correctly on the leads and the contacts that we were holding up. So here we go. I'm saying, all right, Eric, pull on that door. He says, are you touching it? I'm like, I think I am. No, I don't think you're touching it, dude. It's not opening. So, all right, I keep trying to push again, and it's there. Nope. Are you sure you're pulling? Yeah, dude, I'm pulling. Finally, okay. And if this was, a CEO staying in the hotel, his private flash drive, his carry-around money, his party for the evening, his company laptop, everything, that CEOs and CFOs travel with. Just boom, done, gone. All for the cost of, a battery. That's one example. How do you...
Should automatically.
Oh, it should automatically.
Well, when it's done.
Well, that's true.
Yeah.
Vibration attacks. Completely non-electronic attack against an electronic lock.
The attack is a short vibration attack. Puts a tension on the handle, and then you hit the handle with a rubber or a nylon hammer a couple of times.
So you see what happened there? This is just a system that's going to pull a little actuator away. If you make mechanical stuff happen, the lock doesn't know that electrons didn't do that. Bang.
Now,
To their credit.
to be fair, by the way, who recognizes what brand that lock was?
Anybody?
Anyone? You might have seen it at this conference.
Any of the other guys in here right now?
No, so that was a Salto set, but it's fixed.
They fixed it.
It's long been fixed.
Mm-hmm.
It was a defect in the design. They were made aware of it. They fixed it. So now we show this because they were very
So it's
responsive.
still really fucking funny.
Yeah.
You want to tell them about the Omen Zucker?
Yeah. So there are parts of the story that are still a little bit gray, unfortunately. But the basic idea is that there was a company, Ullman and Zacha, and they designed this really neat electronic lock cylinder based on some really nice cryptography. It was a little RFID crypto token. At the time, maybe still is, was very secure electronically, so you couldn't clone it easily or do anything like that. And it was not a cheap lock cylinder, maybe about 250 euros or so. But it had a lot of neat features. It had auditing, it had, time lockouts, etc. And what someone found was that this little servo here, its design was such that if you put a ring of magnets around the lock, then you would be able to generate electricity and move the servo. And just by spinning this ring, you'll see what's going on here.
So the knob doesn't do anything when it's not activated.
So it's slowly moving a servo inside. Meanwhile, there's no audit trail. There's no real evidence that this has been happening. There, it's open.
Bang.
And
That's
then,
where we're starting to see the real tricky part here now.
and then when you want to lock it, you just spin the magnets the other way. So now it's just locked open. Because the electronics don't know that this servo has moved. And now he's going to rotate the devil ring in the opposite direction, and now it's locked again.
And the whole time, the lock does not know this happened. So now you really see the implications of when you start screwing with electronics, the audit trails get way messed up.
Now, just to really touch on the backstory for a moment here, what's interesting is that this magnet, this ring was being sold on a locksmith equipment website for like 15 to 20 euros.
Yeah.
And we took it apart, and you can't make this for 15 to 20 euros. And this was available for sale the day that video came out. So there's some question as to, who found this flaw and how it was released, etc. But the company really did want to,
Maybe another company.
they wanted to fix it, but no one told them about the problem before it was released, which is really unfair to them. But they have resolved the issue now in the most revised locks.
What was the first resolution?
The first resolution, if you had an existing lock, was a firmware update that would that detected whether or not the servo was in the original position. It had a kind of a debug mode, and if it detected that you were using a magnet to open the lock, it would beep.
That's all. It would just beep.
So if you walked up to your lock and it was beeping, then you knew that someone opened it.
We're going to turn the sound down on this one for a second, just let you talk through it.
Okay. So this is another lock, and I apologize for moving so quickly. We just have a lot of content. This is a CodeLocks CL5000 lock. It's actually quite a nice lock. You have one-time passcodes. You have other passcodes. It has a mechanical override that you can replace with all sorts of different cylinders. And effectively, internally, there's a drain hole system. And what Mark Tobias found is that if you take a little piece of wire, all these drain holes, they're lined up perfectly. So you can jam this piece of wire up in there, and if you hit the right area, you can pull the handle and it'll retract the bolt. So at the time, we didn't know exactly what the details were. We knew it was possible.
This is him just going in blind in Vegas at like 2
a.m. I had not done this before. We went to a pharmacy and bought a small spiral notebook because I wanted to try this. And
he looked at it. He was like, "There's no way it's that easy, right? Can I just bang?"
There it is.
There it is.
So you can see the latch is retracted.
Outstanding. Where's our? There we go. But again, no audit trail. The system doesn't know that just happened. Same idea with the Winkhouse deadbolt. The Winkhouse blue chip, another really nice system. It uses encrypted handshake between the key and so forth. But if you have this giant magnet,
The Totus magnet.
Yes.
1.5 years ago, I visited a friend of mine at his company, and he looked at me with a big smile and said, "You're this clever lockpicking guy, aren't you? Now pick this." And he showed me this plastic key with a blue tip, or no, with a blue handle. And it's known as the Winkhouse blue chip. And the Winkhouse blue chip is something that's the next generation in locks, and they're very proud of this technique. And people who know me and who know my background know that I'm into encryption and crypto. And when I first learned about this lock, I was really impressed, because what it does is it uses 128-bit encryption to secure your locks and doors, which is pretty impressive. What it does is, in the tip of this key is a small RFID challenge response.
Because there's just a little pin, there's just a little retractable circle.
And pissed off that my friend told me, you cannot open this lock, and I knew that he was right. That was until I visited my German friends, and what did I see? I saw actually a blue chip, a Winkhaus blue chip lock. And what else did I see? They had the key that does not operate the lock. So there's no transponder in this key. It's a blank key. It's a demo key. And if you insert it into the lock, it will turn 45 degrees.
But the little pin is not retracted down inside.
Will prevent it from turning. Okay, this here is a very strong magnet. And I'm not kidding that it's very strong. If you buy it, it comes in a box. And the box has a big skull and bones on it, saying beware. It's also called in German the Todesmagnet. This has got multiple reasons. One is that it will destroy any hard drive that it comes in. I told you.
So he slaps the magnet on the front of the lock, just has to adjust it slightly.
I'm not sure if you can see it, but...
Bang. And again, the pin doesn't know what's pulling on it.
Now, this magnet can be bought for 39 euros.
And that's a 250 euro lock. So, we want to talk about some of the other ways. Now, that's just physically fucking up the electronics. You can electronically pwn the electronics, and Bobek's pretty great at that. You want to show him how that works? Are you guys still having fun? We got up here a few minutes late. I know lunch is coming up, and are you still enjoying what we got? All right. We don't want to rush too much. We want to give you all the info.
So this is something that some people may have seen before, but it basically amounts to... so RFID is not magic, right? It's just adding RFID to a lock doesn't just make it better. RFID really just is the way in which something communicates. But if that method of communication is insecure, then you're still screwed. You can't see the system being compromised, but you still, if it's not done correctly, then you have some problems. So several years ago, Jonathan Westhuse, for an academic paper, decided he wanted to clone the TI Verichip, which was at the time a very new RFID type transponder. And he went through a couple different designs actually of a device that he called the Proxmark, where he could clone. He could record the information off of the chip and clone it, and then play it back at will. And ultimately, in 2005, he stopped working on the project. He released the Proxmark 3 as open source. All the hardware, all the software you can find online. There's still a community today that makes small revisions to it. A couple of years ago, the MyFair Classic was broken using this hardware. And so it's actually quite capable. It's really nice development hardware. And I have a version here. Again, the board is his design. The antenna I built myself a couple nights ago at the Metal Lab. It actually takes a lot longer than you might think to make an antenna because
passes of wire.
This loop on this side here, it's 100 turns of enamel wire that I had to very carefully do without breaking. But it's a neat system. So older HID proc systems, if that works too. So I'm going to load the Proxmark interface here. There we go. And so we have the device connected. This is what you saw there in the photo. And it has a standalone mode, which is pretty interesting. So it doesn't have to be connected to a computer. If I hold down this button here, so we're in standalone mode. And if I hold it down again, it's in record mode. And so now I have it in record mode. And if you have a prox card, low frequency 125 kilohertz prox card, and you walk by someone, then it records the identity of that card. And now it's saved. It's saved in the memory on this device. And so I am that person. I can walk up to their reader and press playback, and it'll play back that same number. And this can be made, this is kind of large because it's connected to my notebook, but you can imagine that if I have this connected to a battery, and I have this hidden in my coat sleeve or something, then I could easily walk by someone, just bump into them and clone their credentials. And yes, it's true that a lot of RFID chips today are not necessarily vulnerable to this attack. The MyFair Classic attack, yes, has happened, but now Desfire and such, they keep revising it. But my issue with RFID is this: a regular key, if it's compromised, or a smart card, with the contacts, if it's compromised, the attacker still needs physical access to the device in some way in order to perform the attack.
You're going to notice someone going through your pockets,
right,
even if you're drunk or something.
Right. So even if the crypto is completely broken, if you physically secure your card, you're a step ahead. With RFID, it's secure, and then all of a sudden it's insecure. And you don't know if someone has cloned your credentials or attacked your system.
Anybody ever see, there was a show on TV called Tiger Team, where they would break in. It was a show basically kind of about what we do, with guys who look a lot cooler than us doing it. So yeah, it was a red team, and the camera crew would follow them around, and they actually, in one episode, wound up breaking into a jewelry store by cloning the manager's card.
The security device on Jason's front door may be high tech, but the Tiger
They make it look all James Bondy and cool. There's a nice bunch of guys. They're from Colorado. And you see Delchi's reader is basically an older version of this with a really big battery, things that haven't been as miniaturized. So Luke winds up wearing a whole backpack. And if you actually watch the show, if you're from sort of the hacker community, you'll see tons of stuff they've peppered into the show without the producers realizing. For instance, Luke walking down the street, they basically dressed him like one of the DEF CON security staff with the red shirt, the black backpack, the radio right up here. Everything was just an homage to DEF CON and all the other conferences and things like that. So. With the badass music and everything else. But it's cute. It's cute how they did it. And of course, the guy's distracted. But even if he weren't, on a big city street or in an elevator, of course, how often are you going to notice somebody, say, oh, excuse me, I'm sorry. Good day to you, sir. And walks right up, obviously contactless, right in his sleeve, blam. And watch the whole episode. That's the manager's card, so that got them unbelievable access to a system. And later on, when they talked to the guy, he said, wow, how'd you clone my card? Can I prevent this? He said, well, these little sleeves exist that'll shield RF. They cost about 10 cents. He's like, you telling me I could fix $10,000 worth of broken security with 10 cents? Yeah. So for these reasons and more, that's why, electromechanical, much more than purely electronic locks, are really popular. And when we say electromechanical, we're not referring to something like this. This is kind of two locks in one. This is an electronic lock for a container seal, and a mechanical lock separately, but that's not really what we mean. One of the earliest sort of iterations of when companies started to get this idea was the Medico company with their Insight. They had this little contact key that would actually touch into a reader on a wall, and it was an early chipped key. And they said, wow, if this thing almost looks like a key, and we as Medico, we make a lot of keys, what if we put the electronics in a key, and then you could use that key elsewhere. But again, this isn't quite it, because this was, you could use this key in an electronic lock, or you could use this key in a mechanical lock, but it's not purely, truly electromechanical as, let's say, something with miniaturized electronics and motors inside the lock. How do they fit a lot of these sort of devices in a lock, by the way? You may have seen some of our cutaway locks, some of our demo locks, some of our diagrams. There's not a lot of real estate in there. How do they cram it all in? Well, sometimes they can. Sometimes not everything fits. and some guy, is out of the game, and they say, whoops, sorry, not enough room for you. That's kind of an interesting story when you consider something like this Ocelot, the DP. They make a version in their CLIck system. The CLIck is the technology branding by all of the Assa Abloy group for their electromechanical systems. Now in the DP, the standard DP, it's a regular bladed key. Where's the laser? Top. Where's gotcha. So standard bitted key, interacting with top pins, and then this side track, available ever since the Desmo, interacting with side pins. And it's called the DP because it stands for dual pin. You can barely see it, but these side pins are all split. In those chambers, there are actual pairs of pins running together. So in these 5 chambers, you actually end up having 10 side pins. A neat idea, but what Assa said is, boy, if we have all of these side pins, I guess we could afford to, just chop a chunk of them out. And we'll add, electronics in them. We still have like 2 pairs, so we got like 4 side pins. Is that good? Well, that's up to you. It depends on your security model. It depends on your thinking. It should be mindful that that's what some of these companies will do. I think there's an analogy to be had here. I don't know if anybody here, plays Team Fortress or anything, but if I'm going to guard an important doorway, and I've got 2 guys, 2 mechanical machine guns there, and I say, all right, you got to guard this, but hang on, I don't have enough resources. What if I could add some electronics? You don't really want to take one thing away and put an electronic thing in its place. In my opinion, a better way of doing it would be to say, I've got what I've got. Now let's add more stuff to it in the mix. Which would you rather have, guarding your flag or your server room or what have you? That's just my way of thinking. And there are a couple of systems that do that. For instance, the Abloy Protec CLIck system. They didn't take out anything. They just kind of made the whole cylinder a little bit longer. You can see this half is extended. It has the full disk pack and the CLIck element still in there. All you need is a bigger shield around the front when you install it. I think that's pretty nice, in my opinion. How good are these electronics, though? We've talked about fitting them in, but how much do they actually do for you? How well do they work? Well, we will show you their marketing video that tries to describe how awesome they are, and it's awesome when there's 1s and 0s flying across the screen, because that means crypto is happening. This is the video that Assa Abloy says they'll sue people for showing because it's copyright, even though it's on YouTube. So this is a CLIck system. Come on, mouse. How do you? Oh, well. So yes, there's the crypto. It's happening. And this little element just turns, allowing an element to clear. Did everyone see that? Just a small rod had to turn, allowing the whole cylinder to rotate. Now that's a neat idea, but again, how many people are familiar with the fact that when an electromagnetic motor, an electronic motor is uncharged, it's not like a screw or a gear or a chain. It's relatively frictionless. It'll just kind of move however physics pushes upon it. Well, it didn't take long for people to figure out that you can do some really interesting vibration and physics-based attacks against a lot of these CLIck locks.
I got used to multi-lock click keys.
The first time they tried this, they said, this is not going to be that easy, is it? All right, let's try a demo. Did you hear that? The green one has no electronic element. This is the working key. Bloop. Okay, so that works. So the element has spun, and when you remove this key, the lock knows to rotate the electromechanical element back. Yes, Barry, we know it works.
Doesn't have a battery.
So no battery, no element. Now they're using the same mechanical key, which you could conceivably cut at the right locksmith. If you brought in your electromechanical, maybe you know the guy, you can make the mechanical key.
You can see there's already quite some flames in the lock. And the only thing blocking this lock now is the little rotor that I will show.
So the little rotor has been reset by the removal of the other key.
And the trick is, how can we make this rotor move?
Well, how do you bang on that rotor? How do you apply some force?
The rotor. What we have here is a little Dremel tool.
Just an uneven weight.
That's asymmetric. So it will make a wobbly movement. And we go. And go ahead. Let's do this to the key and try to get the right side up.
Just banging, 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 banging. that just makes it all the more hilarious when it's 250 euro, and actually I think this system is about 300 euros in the system. Epic thing. You can see there's already more play, more slop, more movement.
It's open.
Now, what is happening though?
Now, this was the first
When
shot
this key
we
comes
made
out,
today on this
that's
video.
not the electronic key. What do you think the little rotor element is doing right now? It is not resetting. So you come along, you do that, you leave. There's no evidence you were there. Then the legitimate user comes back with their electric key. Their electromechanical key thinks it's turning the rotor, just it's not turning anything. They go in the door, they remove their key, and the rotor resets. So now there's virtually no evidence that anything happened. Really, really freaky stuff. And again, this is all that was happening on the inside. My hastily made animated GIF of vibro attack, blah, 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 blah. It's just shaking, 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 getting that rotor to turn. Really, really effective and really simple. Now that's the old generation. They've tried to make this better with their new generation. They've changed their click element to be much, much smaller. I don't know if we have the new hotness marketing video with even more techie, flashy badassery. Oh yeah, listen to how good it sounds. You know it's secure, there's like an anvil involved. Look at all those zeros, they totally made it more secure. Lightning! Ultimately, same idea. Just they have a better, they have a better sound guy now. But again, small element that turns, allowing an extra clearance on the side. Now, because this system is newer, we're going to show you a few less details. There are attacks out here for this. It's very similar, the key design, by the way, is very similar to something you folk may have seen from the EVA people. The new EVA, the ICS, the idea of a flat-bladed key with side cuts and actual mechanical elements that kind of come in an arching motion is very popular. And that is what Zeiss Icon is using now. That is what the Medico variant of this, called the Medico Logic, is the same key. They have a purely mechanical version, and then they have their electromechanical click-based version. Now the key itself has this little smiley face icon on it that I think is adorable. You think
It's dumb. It's a waste of time and money.
I think this is adorable because when you have the key in the lock, and you plug it in and it says, nope, sorry, wrong lock, and it just frowns at you. Or if you have the right lock and I switch the lock and I go, yay, you can get in. Come on.
Think of who in your company would be impressed by this. And then they're probably the person that actually makes the financial decision. So they knew their target market. I mean, they were smart there.
So that's how the click is supposed to look while working. Now notice again, however, this is the purely mechanical side. If you want to have a cylinder that's not electronic on both sides, you can save some money. The mechanical element, 5 by 5. The electronic side, I don't know if you can see it up there, I spin the lock around, 5 by nothing. Electronic element on this side. Really hard to pick this. I'm not saying that you're losing a whole lot of security, but again, it illustrates that same decision-making model. Again, here's the electronic element, and all people have to do is try to start fouling around with how that works. We have, I think this is going to be video now. This is video of some of our friends. Now this video has been heavily edited. We're going to try to walk you through it verbally without giving away too much. The new version is coming out. It's actually being developed, and it's due to be out, I think, in a couple of months. They're going to start rolling this out. So that was the correct key. Now here is a key that is not programmed for this lock. Now they do something, and the key is turning. Now it's a little bit of a cheat the way the video is edited. Ultimately, what you've seen before involving the reset mechanism, whether a reset properly happens of a proper key, is critical to all of these attacks. So it's an insider knowledge-based attack. It's not like someone's just going to come up with their Magico key and all of a sudden, wham, I'm getting in. But how many people here are aware? What is the percentage of insider attacks? Is it greater or less than most attacks? It's greater. So absolutely. Here is a key that's not even for this lock. This is a Medico Logic with the Icon Verso. So again, these are supposed to be very restricted by territory, but you can actually get keys from entirely other regions, entirely other distribution chains, because they've pruned down their actual supply lines. They just simulated a key bitting on the side, they did their, quote, magic to the internal electro component, and they were able to get it to work. Here we have another demo here where you're going to see, all right, key goes in, you can turn barely, okay, blah, blah, blah. And again, because they took out half of the element, they have one half of the mechanical element, you'll ultimately see what they were able to use. Once they trigger the electronics with the proper key, they can come along with half of a real key and be able to get through in there and get it to turn, again, because the reset mechanism can be messed with in this generation of the lock. So a half of a key, if you wiggle, if you don't have the reset, if you take the electronics out of the equation, wham, absolutely will do amazing, amazing things. Do you want to wrap this up and explain just in case? I mean, it should be really obvious. It should be really freaky what this can involve. But how can, messing with that audit trail, boy, that is some scary shit.
Yeah, so obviously, unauthorized access is kind of a no-brainer. Everyone really, okay, well, they can, a bad guy can get in. But there's other issues too. What if you're not someone on the outside trying to get in? What if you're trying to frame someone? You're on the inside, you do this thing, you steal this information, you destroy something, but you make it look like someone else has done it.
Go in right after the other guy left.
Yep, and then, the if something is missing and they don't know who it was, there's an investigation and you might get caught. But if it looks like someone else has done it and they get fired, the investigation's over, it's done. There's also, insurance implications. If something is compromised and your insurance company says, well, we'd like to see the audit logs, who was in there, and they see that there is no audit log on a lock that supposedly has an audit log, then they say, well, you screwed up. You didn't actually lock anything. It's your fault.
Yep. Potentially tens of thousands of euro in claims that just get thrown out of court. So yeah, remember, please keep all of this in mind when you just throw electricity at a system just because you say, well, I've had this mechanical thing for years, but now I'm going to make it electronic. It doesn't always turn out the way you were expecting. Sometimes it can turn out really, really badly if the electronics haven't been engineered well. And we don't want to say that all these are engineered badly. We just want to say that it's a process. It's a process of refining the designs. And that's why we're really proud of a lot of the companies we're mentioning, even the ones that looked a little bad in a couple videos. They're great names. When they're not trying to sue people, all of them are still revising these designs. And if you are mindful of that and you ask the right questions, you're pretty well protected. So yeah, just be careful out there. Keep it all in mind. This is our one wall of text that we hate doing, but if be mindful. We're not telling you everything is broken and you should all run under your desks and cry. We're telling you that it's possible, it's possible to fix things. You just gotta be mindful.
Our purpose isn't to stand up here and go, be afraid, be very afraid. No, just think more.
Yes. So you can read a whole lot more about why we disclose things the way we do and where new generations of lock are coming from. But you can ask us that during lunch or in the village later or wherever you'd like to. We appreciated being here to have some fun with this. Thank you.
Thank you.
We even left 4 minutes for questions. We are damn good.
So, questions?
They're all hungry. No? Not even questions about how awesome we are? Because we can talk a lot about that.
There's no explanation needed there.
Yes.
Come on, guys, questions.
Yeah.
So for home usage, is there any lock that you recommend that, for example, you can pick?
So for home usage, what do we recommend? I recommend shotguns, but...
But for those who are in the EU who may not have that, no, there's a couple that we like that historically have been very, very secure. The Abloy ProTech series of lock cylinders are very affordable compared to how much security you get. To date, there has been no known public attack. And you'll notice I choose my words very carefully. It's always possible that some government agency somewhere has figured out how to compromise it. But to the best of our knowledge, the Abloy ProTech has not been broken yet, and it's been out for quite some time. The EVA company based here in your very own Bien. They make some really wonderful, wonderful, wonderful locks. The MCS, one of the best in the world in my opinion, not necessarily one of the cheapest. The EVA 3KS.
Give us a free one, please. You hear stuff there?
The 3-curve system is also good. They make a lot of very good locks. If you're looking for something local, if you're based in Austria, EVA makes some really, really great locks that are some of them are quite affordable actually.
Yeah, but in many of these contexts, we're referring to locking stuff up inside of your house, you know, in a box of some kind, not like your front door. Your front door probably has front windows right next to it, and someone's just going to smash in, which can be good. If you come home and your windows are gone, you know to call the cops because you had a really good lock on the door. If the door is a really bad lock, then, well, how do you know no one was in there if you're real paranoid and freaky? There was a question back there.
Yeah, do you see many differences between US companies and European companies regarding to locks? Because I heard that US companies were pretty shitty back in time, and right now, where is it?
Yeah, you want to answer?
So yeah, here's a good demonstration. So you are a European company, and I'm like, hey, Mr. European lockmaker, I found this problem that I think you should look at. This is a problem, yes? We can fix this?
I suppose we could. Please document it, and I don't want to lose my independent, police-verified certification in the marketplace.
Now I'm going to be a US company.
Hey, Mr. US company, I know you had all those ones and zeros, but I found this problem in your locks, and I don't know if it's... Are you? But it's. I can show you how it works. What if I were to show you on YouTube how it works?
So yeah, that's a little bit exaggerated, but unfortunately we don't have a very good relationship with as many American lock vendors as we do in Europe. And interestingly enough, sometimes they're owned by the same company, the Assa Abloy Group, which owns more lock companies than they really should. They own the Medico brand, and when the Medico system was compromised a couple years ago by Mark Tobias, it was very hard just to get them to acknowledge the fact that yes, this is possible. Their own internal engineers said, outright, no, this is impossible. We've tried it, we can't do it. So if we can't do it, you're lying. That's basically it.
So that's kind of the answer. Yes, Sven, right here. And are there hands here too? We didn't see.
So you guys have demonstrated quite a few rather sophisticated attacks on logs. But, well, I do a fair amount of traveling within Europe or the world, and at most hotels, I usually get something like this. This is just a piece of plastics and a magnet stripe. And it appears to me that, well, at least 80% of all hotels use something like that. Is this right that this security is nothing compared to all the stuff you presented over there?
Yeah, most of those locks are made by the Vingcard company, a division of Treaving, a Scandinavian company. They've improved their design over time, but it's still not nearly as secure, simply from a easily clonable standpoint, but also from a breaking standpoint. If you want more info, actually, you can check our talk we did at the Hope Conference in New York called Hacking Hotel Locks. Google either our names or go to my site, deviating.net. Look under videos for hacking hotel locks. There's a whole lot of that, there's a whole lot of other stuff, and it's got naked people in it.
What it really boils down to, and this should be not a surprise, your hotel room is not secure in any way, shape, or form. The hotel safe is not secure in any way, shape, or form. So just understand that the only thing your hotel lock is doing is preventing the casual person from accidentally walking into the wrong room. And that should be the level that you are operating on no matter what hotel you are anywhere in the world, even if you are in a $700 a night hotel in Abu Dhabi who uses RFID tokens that are not secure.
What's the name of the safe? The classical safe, the polymer safe? Yeah, MobiSafe. If you really need to be secure in a hotel, like you are doing field work, I don't know if there's operatives in the room or something, look into the MobiSafe. It collapses down. It's these panels of super dense composite, and you can erect it in a room in no time, lock the whole thing with Alloy Protec, and then at least if you come back from the buffet and the safe is still there, maybe you chain it to something, and you know no one's gotten in at that point. That is one thing you can ask us more about later.